material. These are limits involving infinity. And all we're going to do today is just part of this. We are going to do, as x approaches infinity or negative infinity, horizontal asymptotes. And basically end behavior, maybe not models, but we're going to be talking about end behavior. That's it. So it's short, and the assignment is short, but you may have a lot of questions on the homework. So I am going to graph y equals 1 over x. Well, I'm going to use you can use your regular calculator, but I'm going to use my Inspire. I finally got one of the pieces of software to work. The other one does not work. And I like it because it does pretty print, for one. And I want to do 1 divided by x. I also get a better picture. And it's in color. So that's pretty nice. Unfortunately, I can't just drag it like I do the 83. I actually have to take a picture. And then I have to go down here. This is a real pain, let me tell you. And then I got to go into my camera. Where's my little camera tool? Must be in here someplace. Yes, that. Okay, so I got to bring this up. So it takes me longer to do this, unfortunately. There it goes. Oh, I should be able to just insert it. Oh, that's what I have to do. See, I've forgotten already. So if you're doing science projects, these are nice. You can get the Inspire software free for, I don't remember if it's 90 days or 30 days. Then get the computer software with it. So if you have a science project and you want to print out beautiful graphs, there they are. But what's even better than this, and this is going to be on the iPad, I'm hoping in December, is what they told us, is that you can do this on your computer. I want to zoom out on this, so I'm going to grab my axes. At least my plan is. Is that not neat? I mean, you can zoom out and just press zoom out on your calculator, but this is kind of nice. And now you can see really quite nicely. And by the way, we're only to 20. You know, if you want to go to, let's grab the whole thing if you want to do it. You know, 292, you can't even see it. It's sitting on the axis. Can I move these things? Sometimes you can move these things, but some things, I can move the labels if I don't like them. And there's just other incredible things that I'm still learning about. I was a TI fast tracker, and I had the old software, but there's so many things that have been added, I feel like I'm a novice again. But it's just a nice little tool. So if we use that, we might use this one at least for demonstration. So how are we going to do this? Try it again. There we go. And so we're going to take the limit. As x gets bigger and bigger, and I think you could see pretty easily what it was doing. Now, this is a graph. You need to know what it looks like. There's 10 graphs. You need to know what they look like. I will be working on that if I ever get caught up. But give you a list of those graphs and maybe create a worksheet for you to actually put them in there. So as this is x goes to infinity of 1 over x, what is that going towards? Now, I don't care if it's above or below. It doesn't matter. It's going to 0. This is where you think your way through the problems. Now, does that make sense? If you are talking trillions of dollars, see, a million's 10 to the 6th, a billion's 10 to the 9th, a trillion is 10 to the 12th. So if you put in 1 over 10 to the 12th, if you put that in your calculator, it's going to come out to be 0. So what happens if you take the limit as x goes to infinity of 1 over x to the 10th, for instance? What do you think that's going to be? 0. Make sense? Don't memorize. Just think about it. 1 divided by a huge number is going to 0. That's what this theorem is saying. That if you have division by a variable to some number, that's just a number, that's the power, it's going to go to 0. By the way, I should have said that k is greater than 0. I had to think for a moment. K can't be negative. Why? What if I have x over 1 over x to the negative 10? What's that really equal to? X to the 10th. What happens to that as x gets big? It's getting big, right? Take the budget deficit and raise it to the 10th power. Welcome to your world. Unfortunately, it scares me. It's not going to be easy these next few years. Okay. So, horizontal asymptotes. We'll do this problem. I'm actually going to graph it too. if I take the limit and the limit of my function is some number, call it b, then y equals b is the equation of the horizontal asymptote. There's my horizontal asymptote. So I don't really care what happens at the origin. I only care what happens when I get way away from the origin. Can a function cross the horizontal asymptote? Look at the picture. Can a function cross a horizontal asymptote? Didn't it cross it? Yes. Only thing they care about is way away from the origin. So way away from the origin, it won't be crossing. And then you would say, what's the well, it could be. Actually, it could be oscillated. I think I got one that does that. And what would that equation be? It would be y equals b. That's the equation of a horizontal line. So let's look at that one. Now, by the way, when you do horizontal asymptotes, you really have to look at the limit as x goes to positive infinity and negative infinity. It's not necessarily the same number. Okay, a lot of people assume it is, but it's not. And it comes out on the exam in 2008 where they actually, for the first time ever, threw out a problem. You Google, you can go back and Google AP exams. I believe they started in the 50s. I took mine in 1970. So I wanted to go back and look at it. I thought it was hard. When I go back and look at it, I thought it was hard. It's kind of interesting to see the exams today and exams from before. Okay, so let's take this limit. We're going to take it from both sides. So I'm going to take the limit as x approaches infinity, and we're going to think through this. And this is x over the square root of x squared plus 1. Now remember, this is infinitely large, bigger than a trillion, bigger than 100 trillion, 100 million trillion, as big as you can imagine because there's no end. Now, if you have $1 trillion, you get $1 million. Do you think if somebody takes $1 away from you or gives you $1 that it really amounts to anything? No. So this really looks like this. I'm going to keep the limit in there. As x goes to infinity, it's approximately equal to this. Is that okay? The one doesn't matter. So all you're going to do is look for the highest degree. Anybody know what degree is? I'm going to list type of list of vocabulary. It's the exponent. Okay, so this exponent is the highest in the denominator, 1 in the numerator. Well, let's figure out what this is. As x goes to infinity, this is just x. Now, it's a positive number. What's the square root of x squared? Careful. Absolute value of x. So if you put in a positive large number as x goes to infinity, I really can write it this way. So what number is that? 1. And you would write the equation of the horizontal asymptote as y equals 1. They will ask you that. Because if I have $1 million, I'll give you $1. I'm still a millionaire, right? Yeah. It just doesn't amount to much because you're looking at that ratio. So if you took 10 to the 6th over 10 to the 6th plus 1, it's basically 10 to the 6th over 10 to the 6th, right? It doesn't affect anything. It's way out there. Okay. Now, let's look at negative infinity. Now that plus or minus, that absolute value, makes a difference. With the limit as x goes to negative infinity, you know what I do? I just put in some numbers. In my head, I just put numbers in. Well, this is still going to look like this. It's x over the square root of x squared, which is x over the absolute value of x. Now, x is going to go to a very negative number, like negative 10 to the 6th. That's negative $1 million. And what's going to happen here? Because it's a square root, it has to stay positive. This is positive 10 to the 6th. Oh, plus there's a little 1 there, but it doesn't amount to much, which gives you what? Negative 1. So the other asymptote is y equals negative 1. You're just going to think yourself through these. These do require no work. Yes. Because it's x over the absolute value of x. If I put a negative number in here, the numerator is going to be negative, but the denominator will be positive. Because the square roots are always positive. Yes. I'll fix that in a moment. One of them should be negative, yeah. Can and can't. Oh, you always can. You always can. Well, I got another worksheet. Well, let's look at the graph. Because this is kind of cool. Just got to find it. So I am going to... Now, what you do to get down to the graphing screen is that. But you know what? I'm going to add a new page because I want it clean. Now, that doesn't mean that my graph is gone. Whereas on an 83 or 84, your graph is gone if you clear it out. It's still there. All I have to do is press over here, which you can do on the computer software as well, and I still have that graph. So if you have this on the AP exam and you're in the graphing calculator section, I would just start a new page. And then all of a sudden you're doing a problem and you go, okay, I'm stuck. I'll go to the next one. And then you're in the middle of a problem, and I'm sure this happens. It happens to me. I'm sure it happens to you. And you go, oh, wait, I know what to do. Well, guess what? I can go right back here, and I don't have to re-enter the whole thing and start from scratch. That's a plus. I do have some you can borrow, so if you want to borrow them. They aren't the CXs, but they're still basically the same thing. So let's graph this one, which was X. Okay, so I'm going to put this in here. It was X divided by... Now, I could do this little fraction thing. Let's do that. How do I clear this? There's a little fraction bar here, like on equation editor. Oh, there we go. I just type it in. I'm too lazy to do all that, but that's okay. And then the square root is right here. It's very similar to your 84. And then it's x squared. It's really not that different. Plus, was it 1? You can make it 100. Still going to look the same. That would be a good job for you to do. Make it 100, see what happens. And we're going to graph. It always comes up with this window. I don't have the advantage of, and I just press enter to graph it. Nice. I don't have the advantage of being able to see hold. And then I can move this little label out of the way. And then if we want to, if I want to do this, I can. Because you see now that it's 1 and it's negative 1? Yeah. How nice. Okay, we are going to turn the page. Let me take a picture. I'll get better at this when I get used to it. There it is. So, or when I can turn the page. Sorry, I forgot about the other problem. Okay, now in your book, there is a theorem 5, and all it's saying is the main limit theorem applies to these kind of limits too. You can distribute the limit through that. Now, we're going to read this carefully, though. I've already seen the errors that I know are going to happen. You know what I'm going to do first? Because this says divide. I'm going to divide that. So this is the limit as x goes to infinity. And it's 5x over x plus I must divide sine of x over x again. If you do that, you must divide the x into both of them. You can think of it as 1 over x times 5x plus the sine of x, and then you distribute. You prefer to think of it that way. Okay, let's simplify. Now, this theorem on theorem 5 just says I can distribute that. Guess what? That isn't any different than the other main limit theorem. It's exactly the same. Plus the limit as x goes to infinity. And now you must read math carefully. Reading a math book is really slow. Same with a science book. It's not the same, is it? What's this first one going to give you? What happens to the x's? Because we don't care what happens at infinity. They cancel, don't they? They're the same number, so that's 5. Plus, now be careful with this one. The sine of x is between 1 and negative 1. The biggest it's ever going to be is 1. So it's 1 divided by x. It's smaller than that. It's trapped. Actually, it's called the sandwich theorem. What is that going to? 0. Some of you are thinking, oh, no, that should be 1. No, it isn't. Because this is as x goes to infinity. So this is going to be 0. So this answer is equal to 5. But let's do the same problem and let x go to 0. Because sometimes you need to see that contrast to see it. This is x going to infinity. So when you're on the exam, make sure you carefully read what x is doing. Are we preparing for the exam right now as we go? Yes, we are. We can't do it in 6 weeks before the exam. We have to know it as we go, and you have to retain it. That's something new for you too, right? At least in math classes. Okay. So if I do this one, I really get this limit. Now this is x going to 0, and I could graph it. If you want me to, I will. 5x over x, because I can cancel the x's out because x is not 0, plus the limit as x goes to 0 of the sine of x over x. What's this one going to give you? 5. And this is going to give you 1. So this is going to give you 6. Different than the other one. Do you see the difference? One was going to infinity, one was going to 0. Yes. Because sine of x, good question, sine of x is no bigger than 1, right? Because the sine function looks like this. It's always trapped between 1 and negative 1. So it's bounded on the top by 1. But what's going to happen in the denominator? That's going to get bigger and bigger. So the biggest that'll ever be is 1. So 1 divided by a trillion is getting close to 0. You want to look at the graph? I didn't graph it in the other class. Won't take very long if I can remember what it is. I'm going to add another page. Because now, I messed up. I'll add another page. Graphs. There's geometry, really cool geometry stuff in there. So I want, what was it? 5x plus the sine of x in the numerator. Right? Plus. Now, the trig is right here. It says trig. You could type it in, like an 89. I could do more than you can on the handheld. Sorry about that. Now, where are the parentheses? I'm working with 2 different handhelds, so I don't always know. And this is x. And we will press enter, and we'll graph it. Oh, that was kind of a boring color. But remember when I said when x is getting close to 0, this is getting close to 6. There's a hole there. So tiny you can't see it. And if we zoom out, you can see what it's getting close to. It's getting close to 5, isn't it? Look at that. It's oscillating because of that sine function. It's plus, minus, plus, minus. But if I get out far enough, it's going to look like a horizontal line, isn't it? That's kind of cool. Take a picture of that one, too. Especially when I start knowing what I'm doing, which is about now. That's what I'm doing. Okay. Oh, yeah, if you want to borrow calculators, that's fine, except I do need them for my first hour class. That's the only problem. Okay. So you can see what's happening at 0, and what happens is x gets big. You're doing end behavior way out there. It's like me looking out the window. I can see a finite number of cars. But if I go up to the window, I can see all the way to the right. I can see all the way to the left. I can see a whole lot more. And that's all we're doing. Okay, that's the end of that slide. Now there's another one, and I don't have extras of this for some reason. And this looks like this one. I'm hoping you all have it. It's orange, or I don't know what color it is. Salmon orange. Yes, that color. It's orange. There it is. And it says limit involving infinity 2.2. Yeah, it's stapled. We're only going to do part of it today. We'll do the other one tomorrow. I'll get you one tomorrow. I tried to find extras, I couldn't. Yes. Okay. Which activity? Oh, okay. Now this, you guys did this last year. Do you remember doing this? But they had you memorize something about the exponents. Guess what? Only works for polynomials. So we're not going to do that. And I'm not going to do a lot with this. We'll just do a few problems, and then people ask questions on the worksheet, but we have questions on homework. But I know you have that. Now, if you have polynomials, you can use these little rules, but I don't do that. I just think it's too hard to do those little rules. So if I want to look at This one in particular, I'm going to take the limit as x goes to infinity. It's the same thing. This is approximately equal to, it's not exactly equal to, this function. Now, this is the degree. It's a degree 2. That's degree 1. If you take BC Calc, you have to know degrees. Now, can you reduce that? Because the 2's don't matter. You're talking about $10 trillion. $2, I wish, would matter, but it doesn't. Politicians will all tell you it doesn't matter. Okay, so what's that approximate? What's that equal to? 3x, and x is going to get really large. So what's the answer? Infinity. So there's 3 things that can happen. And they talk about if this exponent's bigger than that one, you get this. Well, and you have some sort of little rhyming thing that works for that. I just look at the problem. You have so much that you have to memorize. You don't want to deal with that. You want to just look at the problem. So let's look at this one. I got the answer there, but it's the limit as x goes to infinity. And these, by the way, are answer only. It's okay. There's no work to show. But this is approximately 4x over 2x cubed. Because the 17 and the 9, they don't matter. So this is going to look like the limit as x goes to infinity. I'm sorry, I ran out of room. But it's what? 2 over, reduce that, x squared. What's that going to? 2 divided by a huge number. I have $2, but I'm going to give my $2 to everybody in the school. Divided evenly. Everybody's going to get nothing. Which makes me think of a story. Mrs. Norton and Mr. Wilkes. You don't know Mr. Wilkes. And then another teacher. He's got 2. We sang at the Mega Mall. There were 4 of us. And I think somebody tossed in 50 cents. So we get to divide it up. It's nothing, right? Okay. So if this denominator exponent's bigger than that one, it's going to go to 0. If the exponents are the same, then all you have to do is look at the coefficients of the highest degree term. Now, I'm talking Greek to some of you. The highest degree term is this, and the coefficients are the 3 and the -2. But I'm not even going to do that. I know there's an x here, but if I make this 10 trillion cubed is much bigger than the 17x. It's going to bother it a little bit at the end, but for the most part, I'm going to ignore that and just look at that. And so what is the limit as x goes to infinity of 3x cubed over -2x cubed? What's going to happen to these guys? They cancel. That's why it works. If you know why it works, then it's easy. Then it's -3/2. Sort of. Because it's not big enough. This is going to overpower that. Let's see, who's the biggest guy in this room? It's like me trying to wrestle with the biggest guy in the room. I'm going to lose. Doesn't mean I don't have any strength, because I do. I can put 40 pounds over my head. 3 weights. But I don't. I'm not. I probably won't even beat anybody, any of the guys. I'm not that strong. This is so much stronger. Put numbers in. That 17x, remember that last one that kind of wiggled? It's just going to wiggle it a little bit. But notice when we went way out, we got rid of those wiggles. So can you do this really quickly? What's going to happen to the 2 and -12? Because they really don't matter. 5x squared minus 6x squared. What's that going to be? -5. Don't make it hard. Some of you are going to say, oh, math has to be hard. It can't be right. It's too easy. Don't make it hard. Okay. I think we're going to turn the page. Pardon? The homework? You already did it, I think. Oh, yeah. Yeah, the homework. If you have everything done, that's great. Okay. What about this one? Okay, you guys, quickly let's do this one. Now, I'll call this example 1, and I'll call this one example 2, so we know what we're talking about. Example 1 should be almost done. 1 divided by x squared. What do you think? It's 0. That's it. I really should have a limit in there to be proper. There's a theorem that says that. If you don't believe me, put in 100. 1 over 100 squared is 1 over 10,000, and that looks like e to the negative 4, and you guys always assume it's 0. It's getting close. Remember, what's the limit? What's the y getting close to as x gets close to a value? Okay, so what about this? Now that's a negative infinity. I can barely see that. What can I cross out? I can cross out everything but the highest exponent. I know the 5x is going to affect the 2x squared. But when I get farther away from the origin, it doesn't anymore. You can go as far away as you want. You go to Pluto. It's not a planet anymore. It's a planet in my book. It always will be. So all I care about is the highest exponent. So what's the numerator going to be? What's this look like? Yeah. This is negative x squared. And the denominator, I'm not going to look at that. Looks like positive 2x squared. Oh, what's the answer? Negative 1/2. You see what I do? I just think my way through it. You don't have time. Just sit there, okay, well, there's H-O, the, I don't know what all that stuff was you guys did last year. Some people did, some people maybe didn't. Okay, now on the worksheet, I'm going to add a page here. We're doing that later. So on the worksheet, 10 and 11 are the same. So let's make number 11 have x go to negative infinity, not positive. That's the blue one. That's the homework. This is all you have to take home. And it doesn't say worksheet 3, but it should. It's called limits at infinity. It's worksheet 3. Number 11. Oh, sorry, I forgot to write that down. Yes. Yeah, you'll have to put in negative numbers. Question is, you have to do something differently if it's negative infinity. Sometimes yes, sometimes no. It depends on the function. So if I wanted to do this, what's the limit as x goes to positive infinity of 5x? That's infinity. Okay, guys? What's the limit as x goes to negative infinity of 5x? Negative infinity. So yes, try some numbers so you can figure out which way it's going. It could be 0, it could be a number, it could be plus infinity, or it could be minus infinity. Should we graph that? 5x looks like that. Oops, let's go through the origin. As x gets big, this is going up to plus infinity. As x gets small, it goes to negative infinity. So number 2, be careful with that. What? Question. That's correct. Now on 3, okay, guys, look at number 3. You're saying that x cubed is going to count. No, it's not. All that x cubed is going to do is make it wiggle at the end a little bit. That's all it's going to do. And you get x big enough, only thing that matters is x to the 4th. Make x be 10 to the 100th power, and just compare the numbers. 10 to the 100th power to the 4th power is much bigger than 10 to the 100th to the 3rd power. So it's infinity. Yeah, I mean, so this is easy. So I would like to look at homework. If you haven't done the book assignment, and I've seen a lot of people who have, which is really good, but if you haven't, you need to do it. You don't know what you need to do. I do. So the answer, it looked like 68 was incorrect. So let's look at 68. Well, I mean, assuming somebody read the answer sheet right. I don't know. So this is section 2.1, number 68. Should there be work? Absolutely. This is not an answer only. I'm on page 68. Interesting that that happened that way, but anyway. I want the limit as x approaches 1 plus. That means from the right. Well, we're going to do this. Well, I could have done it with a table too, but I'm going to do it graphically and algebraically. Now, I don't remember how to do these, unfortunately, because these are really cool to do with the Inspire. Maybe I can, along with everything else I'm going to do, try and figure that out tonight too. I just have to type it in on the Inspire onto in a text box. We'll try it before the class ends, and then I just drag it down onto the axis and it graphs it. Piecewise functions. It's incredible. Never seen anything like it. Okay, I think it helps you to see what is happening if I do graph this. So let's go ahead and graph it by hand. And some of you saying, well, I don't know how to graph piecewise functions. Think of this like as a wall. Now, what are these graphs? What are they going to look like? Are they parabolas? No, what are they? They're lines. We're talking about solution. But anyway, how many points do you have to determine a line? 2. So what's the easiest number you could put in here? It's 0 and 1, because x is less than or equal to 1. So let's go ahead and put 1 in. If I put 1 in, what's the y value? 1, right? And then I can't put in a positive number because that's not allowed. It says x is less than or equal to 1. What's the next easy number? Can't do 2. 0. So if I put in 0, I get 2 minus 0, which is 2. And that's all I really need. You knew the slope was negative 1. That's it. But it stops. It's a wall. On the other side of the wall, the rule has changed. It's x over 2 plus 1. Now, you can put in 1, because you know what? You're going to get really close to 1. What's the limiting value of this? It's 1 over 2 plus 1. So it's 1 and a half, right? Right there. Sorry, it's not very big. Oh, it's not closed, is it? Now you could use slope, or what's another easy value you can put in there? What's the next easy value bigger than 1? 2. So 2 over 2 plus 1 gets you at 2. So it looks like this. Because this is not including it. The way I teach it is, if this has a little extra stuff, it's going to be included and it's going to be closed. So that's a little extra line. It's a little quick trick. That's all it is a trick. Okay, we are now in our car, and we are approaching 1, that stoplight, but from the right side. Which graph am I going to use, the red or the green? The right side, the green. I'm going to come down here. What am I getting close to? What value is that? 1 and a half. By the way, does the limit exist at 1? No. Because what is the limit from the left? It's 1. Could you have just used this algebraically and just used this one because you're coming from the right? Yeah. Is it making sense? If it's not, I know 2 people are coming to see me after school tonight, and I'm in the math office because that's where my last class prep is. And then, yeah. And then I'm here in the morning.